Hello, and thank you for joining us for today's Merritt CX and In-Moment Company webinar. We're glad you've joined us. I'm Melissa Harrett, and I'll be moderating today's event. With me today are our presenters, Peter Robertson and Michelle Turner. We're happy to have them with us, and I'll introduce them more formally in just a minute. Before we get started, we often get asked two questions. First, is this webinar being recorded? Yes, the webinar is being recorded, and you will receive a link to the presentation within the next 24 hours. Second, we're planning to have time at the end for Q&A after the presentation. If you have a question during the presentation, just type it into the question box on your screen, and we'll get to as many of those submitted questions as we can during that Q&A time. You may have also recently seen the news about In-Moment and Merritt CX joining forces. The combined company, backed by Madison Dearborn Partners, a leading Chicago-based private equity firm, serves an impressive list of clients that includes 90% of the world's automotive companies, 8 out of 10 of the leading banks, nearly 20% of the top 50 retailers, and 40% of the top hospitality companies. We believe every experience matters and that business is dynamic and experiences are complex. So we have created a dedicated technology business to address this. We are pioneers in this industry, and we're excited about our joint forces. We've created a unique, agile approach that combines technology and services to provide experience intelligence. We call it XI. And now I'd like to introduce our presenters. With us today are Peter Robertson and Michelle Turner. Let me tell you a little bit about them before I hand it over. Michelle Turner works as Senior Director of Product Management and Marketing at Merritt CX. She has spent her career dreaming up, developing, and launching products that customers can't live without. As a former engineer, her passion is sitting in front of a blank whiteboard with a simple question scrawled across the top. So how do we blank? Peter Robertson has been with Merritt CX for 13 years. In that time, he has held a number of engineering and product management roles. Most recently, he has been working on data management products and has been developing a long-term AI strategy for the platform. He resides in the foothills west of Denver with his wife and his 2 golden retrievers. And with that, Peter, I'm going to let you take it from here.
Thanks, Melissa. Welcome, everyone. So today we're going to be covering a number of things. We've already gone through the introduction, obviously. We'll be talking about what is AI. There's a lot of confusion and a lot of different terms being thrown around when we talk about that. We'll talk a little bit about the data and some of the data required to accomplish what you're looking to do with AI. Then Michelle will touch on talking about how does AI help the experienced practitioner. She'll go through a number of use cases in a case study, and then touch on how do we use AI today. So what is AI? Well, the formal description is the field of computer science dedicated to solving cognitive problems commonly associated with human intelligence, such as learning, problem solving, and pattern recognition. It's been around for a while. The concept for AI first came out in 1955, and it was first described there by the IBM engineers. The term machine learning was first proposed in 1959, again by an IBM engineer who had written a paper based on could you code a computer in such a manner that it would be able to beat the coder in a game of checkers. When we look today, we see that VC investment tops $3 billion annually in AI and AI-related companies. And a lot of that growth has been driven by an explosion in processing capabilities. So when we talk about AI, what are we actually talking about? So there's a number of different aspects to AI. If we start at the top left, we're talking about machine learning, where we talked about things like predictive analytics and deep learning. We have speech-to-text and text-to-speech capabilities. We also have vision, where you can do image recognition and you're able to do facial recognition and those kinds of things. Natural language processing, classification, translation, and data extraction of text. Expert systems, planning and optimization, and robotics. For the purpose of what we're talking about today, we're really going to focus on just a couple of areas. We'll be talking really about machine learning and the natural language processing. We are working with a third party currently on the vision aspect of things to be able to take to take video of surveys and then be able to interpret emotion and attitude from those. They're not in place currently. They're still kind of in a testing phase. More on that down the road. So machine learning, what is it? Learning is the scientific study of algorithms and statistical models that computer systems use to perform a specific task, excuse me, without using explicit instructions, relying on patterns and inference instead. So there's a lot of areas that fall into this. You'll hear terms like deep learning, things like neural net. We're not going to touch on those today. We're going to talk primarily about the concepts around supervised and unsupervised learning. We can see here from the growth of machine learning, this is actually the number of times that the term machine learning is referenced in scientific journals and other publications, and you can see that it's just really taken off from when it first started in 1959. So one of the things that we get asked about here is kind of what's the difference between programming and machine learning? So in its simplest form, if you think about what you're doing when you're writing a program, you're talking about doing an input command that creates some sort of output, an action. So as an example, you might take your input is 2 plus 2, so you're giving the computer a command to add those two variables together to get the result, obviously, of 4. Machine learning, on the other hand, takes a slightly different approach. So rather than using a direct command, its input is data. And what the data does then is it works with the model, and the output then provides the action. So it gives the flexibility that we talk about being able to develop intelligent systems as we go. So supervised learning. When you think about, typically when you've got data, especially when you're looking at survey data, you have a number of your independent and dependent variables available to you. So when you use supervised learning, what is happening here is that it leverages a labeled data set. A labeled data set is one where you have both the independent and the dependent variables are known. It decodes the relationship between the independent and dependent data. So what it's doing is it's looking in this example where we have an automotive example, it's looking at the year, brand, and miles on a vehicle to come up with a price. So it will start looking at all of those, and obviously the more data you are pushing through the system, the more refined that model becomes, and the more effective your analysis around the dependent variable can be. Again, like I said, it uses data to improve the model. It's one of those situations where the more data, the more effective your model can become. Test data can be used to trial accuracy. So typically when you're setting up a model, you want to use about 80% of your available data to develop and build out the model and retain the remaining 20% as test data. Test data then gives you the ability to check and validate that your model is hitting the accuracy numbers that you find are appropriate, and it's giving you the information that you want. Supervised learning is something that you would typically use if you're looking at churn modeling or any kind of predictive analysis, anything where you have a clear understanding of what the various variables are. Unsupervised learning, on the other hand, does not use labeled data sets. It's using an unlabeled data set where you don't necessarily know what your dependent variable is. And so as a result, what it's doing is it's analyzing the relationship between the independent variables to see how those relate to each other. It surfaces hidden patterns. It's especially effective for doing things like clustering. So if you wanted to do demographic modeling, those sorts of things, unsupervised learning would be the approach to take for that. As I said, it's excellent at defining clusters. So when you're talking about putting together a machine learning program, or you're looking to build out your AI capabilities, You need to be able to define the problem you're trying to solve. This is a really critical problem. AI is not a panacea. It's not a button that you hit and you immediately get all your answers. We use a term called the backward research process, start with the end in mind. And so what you really need to be able to do is define the problem you're trying to solve, and then you need to make sure that you have the data available to accomplish your goals. We'll touch on the data in a little bit, but this is where you really need the assistance of people who have expertise in this area, because part of what they will then do is once you have the problem defined and your data is available, the model will be built. Now, there's a lot of statistical models that can be used for this. For the AI work that we're doing, we've used both a random forest and a shade methodology for that. But that's where your data scientist or your data experts can chime in and define what that is. For one of our clients, we have a European client where we were doing using our ISAP product. We built out a model, and we actually ended up having to try 3 or 4 different models to be able to actually come up with one where we could get the accuracy rate to a point that we were comfortable with. So from there, you go ahead and you train and test the model. And as we talked about earlier, if we're using a supervised learning model, we just process the data through that, and we effectively train the model. So one of the differences and one of the cool things around machine learning is the structure is designed that as the data is processed by the model, the model will become more efficient. It becomes more effective. It basically tunes itself as you push the data through it. So from there, you go ahead and deploy the model, but you're not really done there. At that point, what you need to be able to do is you need to be able to go back and check to make sure that we have things operating in the way that's most important. So when we talk about data, this is a really critical component obviously, and one of the things that you have with CX programs is we often have a situation where the practitioner will have access to things like all of the transactional data and other sort of supporting metadata, hierarchy and employee data and that sort of thing. But you may not have access to all of the relevant data. So one of the things about doing the modeling is the more data and associated enriching data that you have, the better your model can become, because it's able to look at a wider range of variables. So this is something that as you're doing your program, you need to be honest about what you may have access to. There's 4 things that we want to do when we get the data. The first is cleaning. So I'm sure you would all agree that data never seems to be completely clean. We talk about this as the process to make data sets usable, and it usually requires some upfront work. We have a tool called CX Workflow that we use for clients to do this process. And the common things that we come across are incorrectly formatted, malformed, irrelevant data. Those are really the most common types. We often find that when you get down to what we call the interaction point, or the point of the transaction, some systems give the end user the ability to enter data that may or may not be completely accurate. So this goes a long way to helping get clean data, because at the end of the day, it's that old saying I'm sure everybody's heard: garbage in, garbage out. Super important to make sure your data is clean. The second step is when we deal with missing data. So this is where you may have incomplete records. For example, you may not have transactional data. There may be missing components. So you've really got 3 options when you're dealing with missing data. Well, 4 technically. We'll touch on that here. The challenge with missing data is it can lead to faulty results, right? So again, it's that whole concept of having complete data. You can leverage the mode as one approach to replace missing data. The other is to leverage using the median value for any additional missing values. If you're really desperate, you can delete the row, but again, that's the whole exercise of removing data, and you may not have enough, but again, that might be an easier way, especially if you're going for a higher level of accuracy where you're not using a median or a mode. And then the final thing you could do, I guess, is you could just ignore it and just move on and hope it doesn't impact things too badly. The third thing we want to do is feature selection. So in this particular instance, you can see that we have two columns. One's in a red box, and the one to the left of it, it's the same data in Spanish and English. So you may not want the Spanish data because it may be irrelevant to what you're doing because it's really just duplicating what you have. The other example here is the country, where you've got the ISO country code, and the country code spelled out in full. So you're likely not going to need either of, both of those columns together, so you could remove some of the data to make the data tighter. The final thing is this idea of row compression. So when we talk about, if you can look at this little chart, you can see we have we have the three different animals. And what you can do with compression is you could change those so you have those first two animals, you can lump them as a carnivore. And the last one. And with that, I'm going to turn it over to Michelle.
Okay, great. Well, thank you so much, Peter. So I'm going to switch gears just a little bit and spend some time talking about how we can harness all this power of AI, specifically in experience management. So as Peter had shared, there we go. As Peter had shared, AI is really not new. But after, I would say, several decades of what I would consider underwhelming advancement, the technology is really starting to provide real, tangible, focused value. I know we can look at our own personal lives just to see this explosion. I mean, most of you probably got up this morning and we use face recognition perhaps to get into our phones. If you got on any online sites, you saw that targeted personalization of your shopping experience. Many of us use the power of a voice assistant like Siri or Alexa. It's pervasive. And I think one of the things that's important is why now? Why have we seen this growth? And there's a couple things that have happened. One, we have the data. We have multiple sources. We have lots of volume of customer data. It has really exploded in the digital era. So we now have near endless amounts of data about customer opinions, about behaviors, from social media to things like wearables to all of the new digital channels of business for companies today. We've also seen incredible improvements in the machine learning algorithms. And, I know I've been involved in the text analytic industry for about 10, 12 years, and just the improvement that we've seen in that technology, a lot of this is in large part due to the availability of the large amounts of data, but also just significant advances in deep neural networks. And then finally, the last thing is that we have much greater computer power than we had in the past. We've really seen the rise of cloud-based services, and that was a big, big step in terms of providing the computational power that we need to run sophisticated machine learning algorithms. So, again, I think if you look to any analyst, there is lots and lots of data which supports this fact that, AI is definitely here and it's on a path with significant growth and a significant trajectory. We are definitely up on the upswing. So the question really is now, how do we leverage this in the CX space? So the reality is that in the world of AI, there's still a lot of science projects, right? There's a lot of AI applications which haven't yet reached that point of maturity where we're really getting the quality of the analysis and the value from it that we'd like to get to. But that said, there are many of them that are proven that use the combination of AI with, machine learning, deep neural networks that can be applied to our space and our business needs. According to Gartner, one of the things that I think is interesting is that we still remain, in their opinion, far from general AI that can wholly take over complex tasks. So we've now entered the realm of what they call AI augmented work and decision science. So again, it's really up to us in terms of how we can purposely harness this and direct it in the world of experience management. So what I want to do is take you through what I think are a couple of the use cases and the ways that we can use AI today that are proven and that are ready and available for us to put into practice. So the first bucket that I want to talk about, and I think one of the first opportunities that we have, is really to help shape and elevate the conversations and the dialogue that we have with customers. As human beings, we want to share our experiences and stories in natural ways, right? And that's typically through conversations. And now as we look at sort of the digital context and the world that we live in, our natural framework for communication and sharing also relies very heavily on images and videos to tell our personal stories. So in the near term, some of those areas of AI that I think are ready for us to take advantage of today are first, text analytics. And this is one of the spaces that I think is most mature for our industry. We have a large portion of our customers that are using it today to help with their unstructured text. But the tools that we have to power this are really shifting. If you look at a lot of the legacy TA systems today, they rely very heavily on rules-based natural language processing. But now the advent of much more sophisticated and effective machine learning models and those deep neural networks are allowing us to move from those traditional rules-based approach, which again, were very accurate, very actionable, but sometimes there was a long time to value, and really shift to much more of a hybrid model where we can rely on machine learning to help us identify topics, identify sentiment, many of which we couldn't get from rules-based engines, and also use that machine learning to continually improve our models. So, this power gives us a variety of things. One, quick time to value, but it also gives us the ability to really fuel more sophisticated analyses, such as emotions, intent analysis. And I think the ultimate value is that it really gives us the tools to be able to facilitate more natural conversations with customers at scale, whether that is through a survey that is heavily skewed toward unstructured conversational dialogue, or even through dynamic surveys where we have branching and logic that's based on sort of real-time text analytics and open-ended responses, all the way to the application of chatbots. So huge opportunity today. The second space is really speech analytics, and this allows us to analyze customer calls or voice interactions for first customer insights, but also we use that very heavily in some industries for employee coaching and performance insights. And AI has really raised the bar in this domain. We've been watching this space for a while, and at a basic level, we've seen huge improvements in the quality of transcription of voice conversations. But even more importantly, I think the real value here is that a lot of today's AI algorithms can also do an excellent job at analyzing speech beyond the linguistic level to really help us look at those auditory cues, such as tone and emotion. For example, one of the things that we work to look at is changes in customer pitch and volume to help detect emotion in the customer's voice. So again, lots of help there in terms of offering some of those contextual insights. And then finally, in our digital space, so much of the big data explosion has been in the area of multimedia. And with machine learning and deep neural networks, we can apply those to images and video, and we can offer a lot of new forms of feedback to customers that are in line with how they want to communicate with us. So one application we provide today at MCX is the ability for customers to offer feedback via their webcam or mobile device. We allow them to really help us humanize that feedback process, which allows customers to tell the story that they want to tell via those rich mediums. But more importantly, businesses then are able to more effectively connect with those customers and really understand their experiences and create more empathy within their organization. So with that AI and machine learning, we have the ability to really unlock a lot of information that's stored in that video content, all the way from basic transcription of text, all the way to things like advanced facial emotional recognition to really help us understand how people feel, and also things like object recognition. which gives us that additional layer of context to our analysis to help us understand where people are and what they're doing. So the other big bucket that I think we've seen some really excellent near-term opportunities to apply AI is to how we process our ability to drive insights and action. So one of the biggest challenges that I think practitioners in our space face today is working across just a myriad of customer feedback sources and data that's available to them. So between the numerous customer voices, from surveys to call center notes to social media, you overlay and combine that with financial, operational, and behavioral data. Most practitioners we see struggle not just to bring that data together, but they also have this looming and ever lurking feeling that they're somehow missing something in that data. And AI has the power to really serve as just as a targeted crawler that can help us perpetually look for insights across those data sources. It really helps us with those unknown unknowns or those emerging issues in your data. It can also help detect anomalies that are outside of, say, normal ranges that we set up that might warrant further exploration. And it can also help develop what I would consider relevant data patterns that when you combine that, say, with a driver analysis and some predictive analysis, we can surface not just the most impactful issues to be addressed, but we can also start getting into what are those opportunities to improve them and some next best actions. Another really interesting application is the ability to add narratives to dashboards. So I think as we really think about democratizing data within a wider organization, which is ultimately what we need to do to make customer experience most impactful, the use of NLG or natural language generation, which essentially helps us take structured data and turn it into narratives or unstructured data, really can help end users, particularly those that don't spend their entire days analyzing data. It can help them understand and interpret what they're seeing. So narratives can add that context. They can add that in the form of a single data chart and being able to add a narrative to that. Or we can also create the ability to look across, say, a subset of data and provide overarching context, analysis, and meaning into what they're seeing and what are the next best actions. So huge technology, which I think has a lot of applications to what we do. And finally, the last one I'll talk about here is really about predicting key scores. So one of the things that we know is that feedback from customers is becoming more and more of a very precious commodity. Many of us have reached their saturation point in terms of what kind of conversations they want to be having directly with a company and its brand. So we have an opportunity to use the existing customer data that we have, along with AI and machine learning, to essentially give businesses the power to act on what customers need without having to ask the questions in the form of a survey or some kind of a customer touch point. So one of the things that we've done at Merritt CX is we've developed a model that we have called ISAT, for implied satisfaction, where we're actually able to calculate a key metric or score, such as, say, overall satisfaction for non-survey responders. This implied score helps us trigger action for interventions with customers who haven't responded to our request for customer feedback. So again, really gives us a lot of lift there. And let me just, what I want to do is just give you a quick insight into the impact, particularly of ISAT, which I just talked about. So if you take an organization with, say, 14 million customers, and if you have an annual relationship survey, let's say they invite 3.2 million customers to participate in this survey. And with a 6% response rate, which is a pretty solid response rate, that might result in, say, 200,000 responses. This is critical data. It's definitely enough to both act on the feedback, to probably set up a top-down CX strategy, but there's a huge opportunity there. If you have the power to be able to extrapolate the data back to your invited survey population, you can achieve sort of a 16 times increase with this particular with this particular case history in Insight. And if you can extrapolate back to the entire customer base as a whole, your exponent jumps dramatically. So in this particular situation, you go from that 16x to the 70x. So again, we have, with the data that we have, a lot more from customers, and they're telling us a lot more than we think. The trick is really about accessing the data so that we can act without being hindered by customer silence. So huge opportunity there. What I want to do now is talk about and really walk through a bit of a case history about one of the probably very near-term and real applications of AI in our space, and also one that typically tops the wish list that we hear from folks, churn. So churn is very expensive for most businesses. And while it looks a little bit different in any industry, the impact of losing a customer is very, very expensive. A high churn rate really forces companies to invest their very finite resources in new customer acquisition just to plug the holes and maintain their current revenues. Even with a really low churn rate, it can really do a number on a company's ability to grow. So this is a quick example of client that we've worked with just to illustrate this. And again, this looks different for every industry, but they have a 3.6% churn rate annually across a customer base of about 60 million. They've got acquisition costs, which in this particular industry in telecommunications typically averages about $400 per customer. So as you can see, when you do the math on that, you're talking an annual spend of about $846 million just to maintain the current customer base at the size that it is. That's a huge investment in just keeping the ship afloat. That doesn't even start to take into account growth rates. So let's walk through a quick case illustration of some of the work that we've done for specifically a large insurance provider to really take AI and machine learning to bring this together against this use case around churn. So the objective that this particular client had was a couple. One, they wanted to be able to first and foremost just predict individual customer churn to do a couple things, both preempt and then prevent future customer policy cancellations. So we did a couple things, and I'll walk you through this in a little bit more detail. But first, we built a model using CX data that we supplemented with operational and most importantly, historical churn data to really create a predictive model using machine learning and AI to predict customer churn propensity at an individual customer level. Second, then we worked with that information to be able to preempt the loss of those at-risk customers by feeding this directly into our case management systems to begin to empower the organization to help with that customer recovery effort. And finally, we are systemically looking to understand the why behind churn so that we can help the organization and they can help drive initiatives to help prevent churn in the future across the organization. So what does the process look like? Just real quick, high-level schematic. First, we start with the CX survey data. We then combine it with the operational and behavioral data. And again, for this model, it was most notably that historical churn data. We looked back about a year. That churn data was appended to the survey responses received over the course of the past year. The data was run through our predictive machine learning engine to define the predictive algorithm for calculating likelihood to churn. In this case, we used the decision tree methodology, and then we were able to use those rules from the tree to create individual customer propensity scores. So like I said, we then applied that to those individual customers to predict their propensity, and then we integrated that into our reporting systems. So one of the things, when we look at the output and we look at the value of this, one of the powerful things that AI does in this particular example is it gave us the horsepower to move beyond that basic customer segmentation to really get a more refined look at the individual customer. So at a customer level, we had those churn propensity scores, and we were able to append those to the individual custom records in the platform. So this is a view of our custom response view. And essentially what you're seeing in this example is an individual customer portfolio record, which includes the complete view of the customer information we have right alongside that churn propensity. So this is available to frontline managers within the platform to help them really tailor, focus any of those one-on-one customer interactions. We then, with that information, one of the most powerful things that I think we did is that we then were able to help create a program where we could preemptively reach out to at-risk customers through targeted intervention efforts. So what we used is our case management solution, where we were able to build rules that would trigger alerts and cases to the appropriate employees within the organization when a customer is at high risk for churn. And again, lots of levers to be able to kind of tweak that, to modify that, and to set a threshold, because again, what that threshold looks like for one client is going to be very different than another client. Through these rules, employees would essentially receive a notification along with that customer profile and some suggested interventions. So we could then, through that case management system, monitor those through a closed loop process to ensure that those intervention efforts were taken and that those employees were really doing what they could in order to recover those individual customers. And then finally, there is also a need to work at a much more systemic level to really prevent future churn and loss. And there's several insights that we can provide. And this is an example, this is just an illustration of some of the reporting that we're able to provide based upon some of that churn analysis and some of the insights that we can get from it. So one of the key questions is, what is my churn risk, right? So what is my churn propensity? And so we talked about what that looks like at the individual level, but we also then have the ability to look at that more in aggregate and across the organization. So not only just as an organization, what are my churn totals, but what does that look like by segment? What insights can we get into who is likely to churn and what we might be able to do for those particular segments? The other thing that we can look at is, what is that financial impact of churn to my business? So what percentage of my revenue is at risk? What percentage of that could be recovered? I mean, that is a huge question that we have. And then I think that the add on to that is then, what can I do to mitigate future churn? So essentially what we're doing here is digging into the why behind churn. We can use tools and techniques like driver analysis to understand what is driving that score. We can also look at things like co-occurrence of text topics with churn propensity. All of this information essentially helps me craft those very focused initiatives within my organization to target and hopefully improve some of those things that are driving future customer churn. So just a quick illustration of that. So as we wrap up, and before we get into the Q&A, I think, again, I hope that you could see that there are many, many very real, very near-term opportunities to harness the power of AI. We are emerging from what I would consider the science project era, where, there was a lot of hype around some of these tools and techniques, but if you really use them, some of them didn't quite live up to the promise. We are moving beyond that. And there are many, many, many very impactful use cases, such as the ones that we've talked about today. So what can you do if you say, hey, what can I do to move forward? We have a couple things that we might offer up. First, and Peter spent a lot of time talking about this in the very beginning, start getting your data house in order. I think that it is a huge foundational dependency to doing any of these things that we talked about here. We've got a lot of big data, a lot of data sources. Being able to bring those together, to clean them, to help integrate them is really the first step. In research from Forrester, they still continue to say that the number one challenge for all AI adopters truly is quality data. The second thing you can do is really focus your efforts. So the truth is, AI can be expensive. It can be complicated. You need to be very focused about the objectives, what it is you're trying to accomplish, and our advice would be start small. Select a use case, ideally with one of the proven AI applications, and really work to play that out. And then finally, is seek out some expertise. There's really no reason to go alone on this one. There's plenty of expertise in the AI space. And we'd love, as Merritt CX, to spend time talking to you more about that, about how we can help you meet your objectives and goals, bring some of that technology to bear. So again, we'd encourage you, if there's anything that you've seen in here that is interesting, to contact your account team to kick off some of those discussions. So with that, Melissa, I think I will hand it over to you, and maybe we can move into some Q&A.
Great, thank you. Appreciate all this information that you and Peter have provided on AI. It's obviously a very exciting time. To the audience, if you have additional questions, please feel free to submit them now. We did have a couple come in during the presentation, so I wanted to kick those off. To start, one of the questions we got was about how to start implementing AI. So obviously you've talked a lot about the various things you can do with AI, but if we just wanted to take one small step, what would you recommend? Michelle, I guess I'll turn that to you, and then Peter, if you want to add, feel free.
I think, Melissa, I think that really depends on your business and your business objectives. We talked through 6 of them. I think any of those are really good candidates. Again, I think a lot of folks are probably already spending time in text analytics, but there's opportunity to truly improve that and make some, step changes by further incorporation of machine learning. But I think it really depends on your business objectives. I mean, obviously churn, which is one of the reasons why we talked about it, is something that is probably near and dear to many of our hearts. So that's always a good place to go. But any of them that we talked about, in my opinion, all 6 of these are fairly proven, and they have technology that really will help support them and help you be successful.
Great, thank you. One of the other questions that came in was, Peter, when you were talking about the models, one of the questions was whether those are automated or if they're custom for each data set, or if you can talk a little bit more about the models and the actual either automation or anything around that. That would be great.
Yeah, so I'll give you a real engineering answer. It depends. The challenge here is the models will typically be used for a specific function, right? Because the models will work slightly differently and give you better rates depending on what you're doing. If you're trying to achieve the same objective, you may be okay with leveraging the data set that you have. But generally speaking, most tools that are out there today will potentially guide you towards a model, but at the end of the day, it will require somebody that does have a data science or a strong data background to be able to determine whether a model will be efficient across two different data sets.
Great, thank you. And then another question probably for you is, what's meant by training the model? Can you give more information about that and whether that means that more variables are fed in, leading to better learning, or what does training the model mean?
Yeah, so basically if you think about it, the easiest way to explain this is that you build your model initially based on a number of different suppositions about what you're trying to accomplish. Then as you feed the data into the system, the model itself, and obviously it's extremely complicated and there's a lot of programmatic components to this, but the model itself will continue to process that data, but while it's doing that, it will continue, if you remember when we were talking about the supervised learning, what it's going to do is it's going to continue to investigate the relationships between both the dependent and the independent variables, and it will fine-tune the model. So effectively what it does is it takes that additional data and it confirms your original thesis that you used to build the model, and it makes your model better. The cool thing about it is it will continue to do that. If you deploy the model into production, it will continue to do that as it receives more data into the system. So it's kind of an ongoing thing. And if you remember where, I made the comment that if once it's pushed into production, you have that arrow that went back to the testing, you do have to kind of continually check on it because you may find that it will build itself to a point where you've got to make some other changes because it's gotten as accurate as it's going to get. So the system, when I say machine learning, it really is the model itself learning.
Got it. Makes sense. Next question is, are the Frontline Manager dashboards and case management solution custom built, or are they a standard offering? Michelle, maybe I'll have you answer that.
I will take that. That's fine. So yes, no, they are standard offerings. The examples that I showed you are within the context of our platform. Some of them are, so the case management is a offering that we offer, Merritt CX Case Management, which has the ability to trigger cases based upon a whole host of things, whether that be structured data or unstructured data. Our dashboards are also standard. Again, this was sort of a custom-built dashboard within that tool set, which was targeted specifically towards churn analysis and the needs of this particular client, but it all sits on top of our standard platform. The response view, again, is part of our platform offering. We did build a custom view of that specifically to meet the needs of the client, but again, that's within the context of the tool sets that we have for our platform.
Great, thanks. And then Michelle, for the example that you provided, can we talk a little bit more about the core types of data that drove churn behavior? Like what types of data were analyzed, text, speech, sentiment, et cetera?
Absolutely, absolutely. So yeah, I think what the question included is that we did rely very heavily on a couple of things. Obviously, we had survey data with a variety of structured data, but we also had a tremendous amount of unstructured data. And we did rely very heavily on the text analytics, the categories, the sentiment, the emotion in order to create that model. We also then had a behavioral component, which allowed us to look at what consumer behavior or customer behavior looked like over the time period from when they took the original survey and we went a year out from that. So those were some of the main inputs, or some of, I would say, the very most critical inputs to the model that we created.
Okay. Next question is, what specific tools would you recommend for machine learning-based text analytics, if any? Michelle.
Peter, you want me to take it?
Yeah.
All right. So I think what I would say is I'd probably give you more of a characteristics that I would look for. So, again, I think we're in this space where supervised machine learning is becoming more effective and more powerful in the context of text analytics, in large part due to some of the deep neural networks and the like. So I think what I would say is that when working with a text provider, we're in a place where I think the ideal scenario is to work with one that has a hybrid model. So what they have is the ability to be able to use knowledge engineering and to use a rules-based approach to be able to create and tweak some of that. But they have that machine learning component that can be used in, particularly a supervised machine learning component, that can be used to improve the model, in some cases build the initial model. I think having that hybrid and the combination of the both is really the sweet spot in terms of where we want to be at right now. I know at Merritt CX, we are working to involve more of our more machine learning, more supervised machine learning directly into our models and our knowledge-based models, which have served us very well from an accuracy and an actionability perspective. I know as a total in-moment company, they have recently launched, and we've recently gotten the technology and are launching the ability to use machine learning to derive sentiment. So again, we're evolving and incorporating more of that as we continue to go. So I guess my advice would be to look for a company as we're looking at CX and looking at the applications of CX that really hits that hybrid spot. When you look at tool sets that use more of what I would consider unsupervised machine learning, they're really appealing and they look really appealing because they can get you insights very, very quickly. The trouble with them is that they're often messy, often very misleading, and it requires a lot of work on behalf of the user and some knowledge of how to work through text analytics to really garner value from them. So I think we do want to make sure that, we have that hybrid and we can provide, ultimately very accurate, actionable, and easy to understand insights from text analytics.
The other thing, if I could just add into that, would be, there's a lot of tools in the marketplace today. And while I wouldn't ever say that one tool is necessarily better than another tool, you need to be really honest about your volumes and what you're trying to get out of it as well. You can look at a tool like a Domino Data Labs or a Watson Studio that are awesome tools, but they're not really designed for lower volume situations. So be real honest about what you're trying to accomplish with this, and also the volume of data that you're looking to be able to process.
Great, thanks. Last question. How do you avoid bias in the model as it learns from past experience that could be flawed?
So that's a great question. And the easiest way to explain that is why it's really important to have the appropriate level of expertise when you're building that model. And that's the one thing that would concern me about a kind of one-size-fits-all approach. I know some companies out there and some in the AI space have a tendency to do that. We recommend that you typically would have deep data science involvement before you push the model out, and that's going to be your best way to avoid any kind of bias being introduced into the model. For example, one of the ISAC customers we worked with that I touched on that we did the work for in Europe, we actually spent 2.5 months with our data science team building and working with the client to get more data, but building the model so that we could get one that was the most effective. I think we actually went through 6 or 7 different models before we actually landed on one that we felt would work with this individual's data.
Perfect. Okay, well, that is all the questions we have, and that's going to wrap up today's event. Thank you, Michelle and Peter, for your presentation, and all of the audience members, thanks for joining. If you have any additional questions, please don't hesitate to reach out. And with that, all of us at Merritt CX, an in-moment company, thank you for your time, and have a great remainder of the day.